Okay, so the math problem we're going to do today is from the 2012 AP Calculus AB Free Response, question number 6, and it deals with a moving particle. The first part of the question asks you to evaluate where the particle is moving to the left. We know that a particle moving to the left, the velocity has to be negative. Therefore, we can use the velocity equation they gave us and look at where it is less than 0. So the equation will be velocity equals cosine pi of 6t less than 0. To find the solutions to this equation, we can graph it on our calculators and then use the second trace 0 button to find both zeros. And then we find that there's a 0 at 3 and a 0 at 9. Looking at the graph, we see that, therefore, from 3 to 9, the velocity is negative, which means that the particle is moving left. The next part of the question asks you to consider the total distance traveled by the particle from time 0 to time 6. So since it says total distance, we're going to use an integral expression, and total distance is expressed by the absolute value of the velocity. We can calculate this on our calculator by doing math 9 to get the integral sign, and then math number 1 to get absolute value. And so then we find that our solution is the integral from 0 to 6 of the absolute value of v of t is 3.819. Part C of the question asks us to find the acceleration of the particle and then use this to determine if the speed is increasing, decreasing, or neither at time t equals 4. So first, we know that the acceleration is going to be the derivative of v. And so we can use this, the v equation, v of t equals cosine pi over 6t, to find the derivative of v, which is going to end up being negative sine pi over 6t, and then chain rule that out to get times pi over 6. Then we can use our calculators to evaluate these two equations, and we get at 4, the acceleration is negative 0.453, and the velocity at 4 is negative 0.5. Notice the fact that both the acceleration and the velocity have the same sign. Because they both have the same sign, that means that the speed is increasing for the particle at time equals 4. The last part of the question, part D, asks us to look at the position of the particle at time t equals 4. Since we know that the position is the integral of velocity, we're going to use an integral to express this. It's going to end up being the integral from 0 to t of v of t plus the starting position of the particle. We can plug in our numbers there, and we get the integral from 0 to 4 v of t plus negative 2, our starting position. And then we can use our calculator to solve for this. You do math 9 and to get your integral, and then you can enter in the values as they are, and you'll get negative 0.346 as the position of our particle at time t equals 4. And there you have it. You've solved the entire problem. Good luck getting that 5.